Hello everyone. Today we are going to discuss problem number C under electrostatics in plus 2 physics. Consider an electron traveling with the speed v0 and entering into a uniform electric field E, which is perpendicular to v0 as shown in the figure. Ignoring gravity, obtain the electron's acceleration, velocity and position as function of time. So this is y-axis, x-axis, and this is negative potential, positive potential, and the direction of the electric field is this. That is along y-axis. Positive y-axis is the direction of the electric field, and this is the direction of v0, initial velocity. At the point it meets the electric field, the velocity of the electron is v0. So v0 and E. V0, this is the direction of V0 and this is direction of electric field. They are perpendicular to each other. After the electron reaches the getting into the electric field, it will experience the force due to the electric field. That is, this negative potential will exert a pushing force on the electron in the downward direction. So the path of the electron will be like this. And here we are going to derive the expression for acceleration, velocity and position as function of time. So for that we are considering our familiar expressions. F is equal to ma and F is equal to qe, where q is charge of the charged particle. Here the charged particle is e, I mean electron. So its charge is minus e. F is equal to minus e. So F vector is equal to m into a vector is one of the expression we know already. And F is equal to QE is another equation. So that is modified into minus e into e for the electron. Now we can equate these two expressions. So equating 1 and 2, we get m into a vector is equal to minus e into e. From that the expression for a is derived as minus e into e by m. That is minus e into e vector can be written as e into ej. E vector is equal to e into, not ej. E vector is equal to e into j cap. J cap is the unit vector along positive y-axis. So because the direction of the electric field is along the y-axis, so E vector can be written as the magnitude of E into j cap. So therefore the expression for A becomes minus E j cap divided by m. So this is the expression for A. Now we are substituting the value of A in the well-known equation for velocity. That is, velocity is equal to initial velocity u plus at, and the value of u also is substituted. In our case u is v0, the initial velocity of the electron is v0, and acceleration a is minus e j cap by m. On substituting these two values, we get the expression for v as v0 minus e by m in t into j cap. Now this v0 vector can be written as v0 into I cap, because the magnitude of v0 is purely along x-axis and its y component and z components are 0. So v0 vector can be written as v0 into I cap. In the same manner here also E has been replaced by E into j, because this vector E is purely along y-axis and its component along x and z is 0. So we have written E vector as E into j cap, and in the same manner v0 vector is written as v0 into I cap. So this is the final expression for v in terms of t. In the same manner we are substituting the value of v and u in the expression for position. The equation for position is ut plus half at square, and the value of a also is substituted. So r becomes v0 t into I cap minus e t square by 2m into j cap. That's all about this problem. Thank you.